Alright guys, so I am going to go through how to set up your graphs and answer these questions on the first one of your photosynthesis graphing papers. So the first one is the effect of carbon dioxide on the rate of photosynthesis. So as we know, carbon dioxide is one of the reactants for photosynthesis. So without carbon dioxide, photosynthesis can't happen. So we're going to use the information in the table below to produce a graph to show how increasing the amount of carbon dioxide increases the amount of glucose a plant produces in photosynthesis. So we have our independent variable, which is our carbon dioxide, and it's going up in increments of 10. And then we have our dependent variable, which is the amount of glucose produced in an hour. So the amount of glucose produced depends on how much carbon dioxide is available to the plant. So first thing we're going to do is use your graph. Oh no, we're going to do this first. So first, remember we have to do talks. So first we have our title. So our title will be the effect of carbon dioxide on the rate of photosynthesis. So remember, our title should include the independent variable and the dependent variable. So independent variable and rate of photosynthesis is our dependent variable, which is our amount of glucose. So our independent variable will go on the x-axis. So we have amount of carbon dioxide. And on the side, we have amount of glucose. Per hour. And that's in grams. We have to make sure we include our units every time. So we have title, we have axes, we have our labels, and we need to put our, there's no need for a key because this is going to be a line graph. So we're going to have 0 here. We're going to have 10, 20, 30, 40, 50, 60. Now, could I have used my space a little better? Probably, yes. So as you're doing yours, I would try to spread it out a little bit more, but I'm just trying to get a quick example for you, okay? Now we have 0 to 20. 20 is our highest up here. So I'm going to put it right here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh man, that almost worked out perfectly. All right. So I'm going to do 5. So 1, 2, 3, 4, 1, 2, 3, 4, 10, 1, 2, 3, 4, 15, 1, 2, 3, 4, 20, and then I'm going to scratch that out. All right, so now I'm going to graph it. I'm sorry, it's shaking so much. All right, so 0, 0, we're starting out at 0. So no carbon dioxide equals no glucose produced. Then we're going to go 10. So we go over to 10. And when I have 10 grams of carbon dioxide, I'm going to get 5 grams of glucose produced in an hour. So check, check. Now I have 20, go over to 20, and 10. So when at 20 grams of carbon dioxide, I get 10 grams of glucose. Check, check. Now I have 30, so over to 30, up to 15. At 40, I have 18, so that's a little bit lower than 20. At 50, I get 20. And at 60, I get 20. So then I'm going to connect my dots. We're leveling off. All right. So now it says, using your graph, work out how much glucose per hour would be produced with 25 grams of carbon dioxide. So 25 would fall in between 20 and 30, so I go halfway between, and I'm going to go up, and that's going to be about 12.5 grams. So when I have 25 grams of carbon dioxide, I'm going to get about 12.5 grams of glucose per hour. Number 3, why do you think the level of glucose produced per hour does not rise above 20? So at this point, what's happening is the more carbon dioxide we have, the more glucose we get. And then at a certain point, our plant can only process so much carbon dioxide in an hour. So that's why it will never get above 20. So our plant can only process so much carbon dioxide in an hour. If you were growing plants, what amount of carbon dioxide would you use to grow them to produce the most glucose for the least amount of money spent on lighting? I think it's supposed to be spent on CO2. So where am I going to get the most amount of glucose for the least amount of carbon dioxide? And that's going to be 50, because why waste my money getting 60 grams of carbon dioxide when I can get the same results with 50? So 50 grams CO2. How would you control the amount of carbon dioxide a plant gets? I could put it in a container that I can control the airflow. And then number 6, design a short experiment to prove how much glucose is produced by a plant per hour at different amounts of carbon dioxide. So I would put plants in different containers and input the carbon dioxide myself and monitor it for, let's say, 12 hours. All right, and that's all there is. And you're going to do the remaining 3. So amount of temperature, or the effective temperature, the amount effective water, and the effective sunlight. And that's why this, and this.